Oh, let's start with, yep. First of all, we are celebrating Silver Jubilee event today. So it is our 25th event. So thank you to all the participants so far who joined us in as an audience or as a speaker. So thanks to everyone to make us to reach 25th. So yep. Go to the next slide, Vijay. Yeah, today we have a topic called NFRs, non-functional requirements, how we are going to handle with using API policies. And yeah, before going to the topic, we have some safe harbor statements. Both the speaker and host, we are organizing this meetup at our individual capacity only. We are not representing any our organizations here, and this is strictly for learning purpose only. We don't hold any responsibility. The same solution will work for your use cases when you are working with your problem statements. And this is not for any promotional activity. This is just for a learning purpose. And before going to the next one, the housekeeping rules are there. And yeah, this meetup session will be recorded and uploaded into the event page on the same day. And if you have any questions, please put up in the chat, and then or else you can stop us there and there, and then you can ask. Better, I recommend to post in the chat. We can take up at the Q&A session, and please make it interactive session. This session should be an interactive session. So if here we are not like just one way. It should not be a one way. So it should be an interactive session. So please provide your feedback. Your feedback is very important to us because we always want to bring some insightful topics always. Based on some inputs and feedbacks only, we are coming up with some topics what we have delivered also in the past. Yep, your feedback is very important to us. Next slide. Yep. We are two organizers for this group. Shubham, you're there?
Yes, yes, Giri. So, hi
Yeah,
guys.
you can.
Yeah, so welcome everyone. So, I'll quickly introduce myself. So, I'm working as a professional integration developer in Millennium. Got all MuleSoft certified. So, yeah. So, thanks everyone for joining. So, what do you?
Yep. Thank you, Shubham. Coming to me myself, Giridhar. I have overall 14 plus years of experience in the industry and majorly in the integration area. I'm also a certified architect in both MuleSoft and AWS. I'm also holding most of the MuleSoft certifications. I work at Hasdin as a senior architect. I'm leading this Mysore group and I'm a mentor too. That's about me. And today we have Vijay. Again, he comes up with a nice topic like how to handle non-functional requirements for any API using API policies. So actually, he want to cover up both out of the box policies and custom policies. So since we want to give a complete knowledge on this part, we have split into two parts. Like today, what we are going to cover is out-of-the-box policies. This is we call it as a part 1, and then part 2 will be covered. Part 2 will be the custom policies. That part 2 it's supposed to be happen on 4th February, but for unexpected reasons, we postponed that session to 11th February. So second, I think that is the second Saturday of the February. So, well, today Vijay will walk us through out of the box policies. Here you go, Vijay.
Yeah, thanks to Giri. Just before starting, so the recording is on, right?
Yeah, yeah, it is on.
Okay, thanks. Hello everyone. So I'm Vijay Raghavan Angada 3, and I'm working as an integration architect and being associate technical manager in Ernest and Young GDS, and I'm having like over 11 plus years of experience, predominantly on the integration and API products spanning across IBM MuleSoft and cloud technologies. And I'm being a MuleSoft mentor as well as a speaker in the MuleSoft community. And like I have like 6x certified in IBM Stack and 2x certified in MuleSoft and a few things to it to go. So as Giri has given a brief introduction on how what we're going to see today. So these are our agenda. So this is our kind of part 1 session. So where we are going to cover about the out of the box policy first. Even before going to the out of the box policy, like first we discuss about what is NFR for an API, and then how you can going to deal with the NFR using the API policies. And when we talk about API policies, then that's where your out of the box policy comes into picture, and how the API policy enforcement happens in the MuleSoft layer. And we'll discuss on each policy. And so here, like we are going to discuss in most of the policies. Couple of policies I kind of move to the next session because of the time constraint. I will explain what are the things that we are going to cover in next session as well. And then we'll discuss about couple of use case scenarios, and then followed with a short demo. And then we're ending up with a Q&A session. So these are the today's agenda. So let me go to the first slide. So let's talk about the API's non-functional requirement. So ideally, you guys know what is the requirement in first place, right? So when we talk about the requirement, ideally we deal with the functional requirement of what is required to build the integration solution, right? So what is required to do the system integration between two different systems. So those are comes under the functional requirement. But when it comes to the non-functional requirement, the NFR itself vast area to have a huge discussion. Like ideally, like put on a nutshell, we can tell that what is the NFR is. Like it will define your the behavioral and how the your functional implementation to be guarded and performed in real time. Okay, so that's I would say in a nutshell. But when you deep dive into it, there are various category that we can do the segregation. Okay, so when it comes to MuleSoft, so we do the AP first approach design. So that design having NFR that is going to define that how that particular web API implementation should perform and react upon when there is a API invocation happens by the web API client. So ideally, at the end of the day, that's just going to be the web API invocation from your your source system. And so through a web API that goes to talk to your corresponding mediation or the target system. So the NFR defines here, like how your so when the web API invocation happens, how your web API implementation should react, or how your web API implementation should perform. So ideally, we can like kind of like categorize, or I would say classify into few categories of NFRs that we can talk about, like the performance of it, the security reasons of it, the compliance of the API, and the consistency and the reliability. So these jargon terms probably we can discuss more in the upcoming slides, but we classify, we do the classification on under these terms. And how do you handle NFR? So there are various steps to handle NFR. It is not just with the API policy. It's all about like the other aspects we are going to cover. The first one is like where it is getting deployed. So what is this infrastructure is, how it is really scalable. So for example, with respect to the one of the deployment model we have Cloud Up, so which is a high performance runtime plane, which is going to have a high scalability in terms of being a very horizontal scaling or the vertical scaling, which is definitely going to handle your reliability and the performance of your API, which is going to increase your throughput and the processing time. Okay, so your deployment model as well will decide the NFR of your API. And apart from that, how you're going to design your API. So how you're going to design API is something that how reliable your API is going to be, and how stable your API is going to be. Like for example, like making your API fault tolerant, and making API like in terms of implementing caching, and uh, implementing reliability pattern. So these sort of comes under designs. And the third point here is that's where comes the API policy. So API policy takes care of few important aspect in terms of the security, compliance. Also it defines your quality of your service and operations. So that's where the API policy we're going to talk about today. And when you're going to talk about the API policy, that's where the out of the box policy comes into picture. So ideally, this out of the box policy is nothing but like whatever is readily available when you purchase a new product. Okay, for example, if you take instance of this picture, so when you buy a TV, right? So immediately along with the TV, you're going to have a feature of a remote control, so that you're going to use it. So that is the kind of like reference point we can make it here. So when I say when you purchase a MuleSoft any platform, immediately you're going to get couple of handful of API policies in multiple category that will help you to handle the NFR of the particular API implementation. So that's where we are calling it as out of the box policy, which is readily available. It's just kind of a plug and play framework. You have to just plug it out to your API, and then do the configuration according to your need, and then just play around it. And the categorization of the out of the box policies are like, we have compliance related, we have security related, we have quality of the services, also we have transformation and troubleshooting. So we are gonna just see high level of what are all the available policies we have in the list, and then we'll discuss each one of it in detail. So with respect to compliance, we have two policies, which is client ID enforcement, and then cross origin resource sharing. And when it comes to security again, we can do the sub classification. Like first we can talk about the HTTP basic authentication, where you can have the authentication of your be it a simple authentication, or it could be LDAP authentication. And IP based policies, like you can control the traffic to your API using these policies, like kind of IP block list and IP allow list. And the next one is the security is like, in terms of threat protection API policies, which is like guarding your your API from the payload threat. So that's what we have, like JSON threat protection and as well as XML threat protection. And most importantly, we have over 2.0 access token enforcement API policy, where you have multiple option with to interact with the specific OAuth provider, like Ping Federate, OpenAM, OpenID Connect, as well as MuleSoft provides in-house OAuth provider to handle the OAuth 2.0 implementation. Also, we have additional API policy in terms of security, that is JSON Web Token validation, and the next one is tokenization, detokenization. So these two policies we are going to look at in terms of the next session. Okay, along with the custom policy. So only whatever the list that you are seeing here today, we are going to have a discussion on this point. And the next one is quality of service. So what is the quality of services? This is something really significantly aspect of guarding your API to be able to to be a stable one. That is like controlling your traffic, or more than controlling, I would say, like regulating your traffic to the API. So that's where we are having like policies related to the rate limiting, which could be a SLA or non SLA. And then we are also having a spike control policy and HTTP caching. And there are other two categories, which is transformation, where you can like manipulate your HTTP headers in the request as well as response part. And finally is a troubleshooting, like doing a message logging, like what type of messages. It could be payload logging, it could be a specific custom value logging, or it could be a attributes level, header level logging. So for the troubleshooting purpose, these are the readily available API policies for your subscription, and you can just go and plug it out to your API, and to handle your API for the NFR perspective. So let's kind of before going to the policy level details, we'll have a short discussion on what is the API policy enforcement. So currently we are having API policy, and you can take any type of policy that you want to plug it out to any of the API to handle your NFR. But how this is going to enforce at at runtime? So that's where the question comes. So in MuleSoft, whatever the runtime plane you have for all the Mule application, the runtime agent having the capability of like enforcing the policy. So what it does is, irrespective of a runtime plan, right? So be it a cloud hub, or it could be a a runtime fabric, or it could be a on-premised version, or it could be AWS public cloud, in a government cloud. So any type of runtime plan, the whatever the Mule application, you don't need a separate gateway that has to do the enforcing. So the runtime itself having a agent, okay, which do the which has the capability of like enforcing the API policies. So how does this, whatever the API policy you are going to configure for the API, it will get downloaded to the runtime. So how does it download to the runtime is through the API auto discovery. So I think I am sure, like most of you guys are aware of what is API auto discovery. Okay, But this is for the point, like, if you are like, new to this section. So the API auto discovery is a feature, which you can, let the runtime to know to, download the API policy from the API manager, which resides in the control plane. So there are two planes which you already, which you guys already aware of. That is control plane, the runtime plane. So whatever the API policies you initially configure, everything that sits in the runtime plane. So that runtime plane, so that's a control plane, will have the API policies. So as in when you deploy your, Mule application into the, runtime engine, so before the application gets started, it the, the runtime engine will, download all the API policies from the control plane to the runtime plane, and it will enforce it. So once that particular piece of, process gets completed, then only your application will up. So, and then, so whosoever your API client, going to invoke your API, has to go through all this API policy, whatever you configured before, reaching to your actual web API implementation. So this is how, the API policy enforcement happening in all the Mule application you are deploying to, any number of, any type of runtime plane. And the second one is API proxy. So API proxy are, specifically defined for non-Mule applications. So in your enterprise, you want to use the endpoint platforms for just to, kind of, act as a API gateway. But whatever the API implementation, like, you've developed in, other technologies, I would say, like, it could be, some REST API you expose from your Java based, implementation, or it could be from other ESB products. But they don't have the capability of, implementing, doing the API governance at that particular APIs. So that's where, you can include, API proxy. This API proxy is again kind of, Mule application only, if you talk internally on a technical point. So you have to, you kind of, expose this API proxy in the runtime plane. And when you expose it, so again this is going to kind of, have all your API policy downloaded to that. And the API client who's going to call the non-new applications, they have to go through this API proxy. So the API proxy is something being invoked at first point, and all the API policy that you have configured for the API will be enforced there. And once all the validations succeeded and all the authentication and authorizations are succeeded, then the API proxy will route the traffic to the non-mule application where it's there in the, within the corporate network. So this is the, one of the API policy enforcement from the API proxy perspective. What if, your non-mule applications are, running, within the Kubernetes cluster? So the Kubernetes clusters, you have managed solutions like, Amazon Elastic Kubernetes Service, or, probably Google Kubernetes engine, or Azure Kubernetes Service. So you have, multiple managed solutions. So that's where there is a, another feature called Anypoint Service Mesh. So this Anypoint Service Mesh, can be installed in the Kubernetes cluster, so which will act as a, single point of proxy for all your, API. For example, if within the Kubernetes cluster you have 10 non-null applications deployed to that, okay, and the API client has to make a call to those things, but you need to guard those APIs, by enforcing your, policies. So how you can do that is using the Anypoint Service Mesh. You can guard all those things. So this Anypoint Service Mesh is kind of, installed on top of Istio. So your Kubernetes cluster should have the Istio. And with respect to the invocation, the API client may not need to call the Anypoint Service Mesh. They can directly call the non-mule application, but this Anypoint Service Mesh kind of, intercepts the traffic, and it will enforce the API policy on the request and response types. So this is how the, API enforcement policy is happening, with respect to this three different category. So let's get into the API policies, which is the main, topic today. So first, let's talk about the compliance related API policy. So first, we are going to see about the client ID enforcement. So the client ID enforcement is, is used to identify your client. Okay, so this is something, you guys are, previously kind of aware of. So this client ID enforcement is something like when a particular API client, register themselves, to an API, and as part of registration, a client ID is provided to them, and as a secret, there is a client secret is provided for them. So they have to pass it on, or they have to supply it during the API invocation. So this is just a, compliance perspective for the API to identify the clients, the corresponding request that is coming from the valid client. Okay, so that's where this compliance API policy is available, and this particular this client ID, client secret parameters can be configured either from the query parameter, or it could be from your HTTP custom address, or it could be your basic authorization address as well. So in three parameters, this client read client secret are being accessed, and the API policy will find out, whether these client ID client secrets are available. And you may have a question like where this client ID client secret are residing for validation perspective, because the client is passing the client ID client secret, but the platform should understand, the platform should able to validate those. How it can be able to validate those? This the client ID client secret are within the API control plane itself, where when you're registering for the API request. So it having a in-house capability of generating the client ID client secret, and it will validate against within the in-house capability. And as part of the validation, once it's success, then it will allow the request. Okay, and this compliance is kind of interrelated for the quality of service as well, which is related to the SLA tiers of rate limiting that we will see in the upcoming slides. But this is kind of this particular client ID enforcement is not just only for just for the validation of client, also for defining the SLA tile for tier for the specific clients. And the next one is cross origin resource sharing. So this cross origin resource sharing is something probably you guys are aware of, or if you might be new to this. This particular policy is very important policy if it required for any of your web API client, which is your website, which the website is making a direct REST API called your MuleSoft layer. Okay, in general, the CORS is a general protocol. Let me give you an example. So you have a you have a particular web page. Okay, and so that is going to talk to a server, so where actual the implementation is available. Here, assume this particular server is like kind of access to your browser. So this is your computer and you have a browser in it. So let me go to this. So this is your browser. So this is your browser, and which is residing in your machine. And when you're going to open a particular website, probably let's say you're opening any e-commerce website. Okay, that could be an Amazon. So that Amazon website hosted in a server. Okay, and the call goes from your the browser to the actual Amazon server to get the details. Assume that this Amazon server having specific details required from a different third party system. Okay, and the particular code that is available, like the Ajax call that is going to make, okay, it goes to one API layer. Okay, let's say some order information kept in a third party, and this is the API server. So what happens here is, in general world, the same origin request only accessible within the browser. Okay, so when the page is getting loaded in the browser, it talks to the server and whatever the page that is available. So when I say the server, right, so let's say this is like www.a.com. So the browser expects whatever the data that is going to get displayed in the browser, it should be from the the same origin, that is www.a.com. And if it finds out that this particular page is making a call to another server, let's say this API server is www.b.com, and the call goes to here to get some additional information to display the in the browser. So what happens is, this is called cross origin. Okay, the base origin is the actual server where it is where the website is hosted, And when it is going to make a call to the API, which is going to another server, that's where it becomes a cross origin. Ideally, this request will be denied. You will not able to get to it. So that's where the cross origin policy is required. So what it is expecting is this server has to say that you can allow a request to this from this particular server. So how it can allow a request to this is something through the headers it will talk about. So there is a in ideally in HTTP world, we have idempotent methods which are get methods, which are saved, and also we are having altering methods which are post, put, and delete, right? So for those methods, this particular server has to confirm that the browser can allow a request from the a.com to the b.com for these kind of activities. So that's why this cost policy comes into picture. So this particular browser will kind of do a pre-flight call. So it uses a HTTP header called options. So through options it will confirm that this particular a.com is available for doing the cross origin. So if it confirm, then the browser will allow the a.com server a.com server to make a call to the b.com server to get the responding data. So how this is happening is, that's why this cost policy. So you are the server, from where you're going to get a request. So in order to apply this cross origin resource sharing policy, so you are just going to configure the actual server details in your policy. So by doing so, on the pre-flight calls, you are going to respond back to the browser stating that the call can be allowed to this to the API, I mean to this server from this particular origin. So to talk about this in detail, let me just quickly go to the cross origin here. So this is how you're gonna configure your policy. So you have to define your origins of where the request is going to come up. So through this, what you will be doing is you can define what are all the methods you can allow for that particular origin. Or if you want to define more than one origin, that is also fine. You can do it by doing the comma separated. And by doing so, this policy will give the origin headers back to the browser, mentioning that this particular request is allowed. So there are headers available which can keep that as an identifier, so that the browser will allow this the website to make a call to the MuleSoft layer. So this is how this particular policy is being used. And the next one is security. So whatever we have seen so far is a compliance. So there are two policies in the compliance, which is client ID and then cross origin and resource sharing. Now coming to security, first we are going to talk about the HTTP authentication. So the HTTP authentication, we have two options, which is simple authentication and another one is LDAP authentication. The simple authentication is something that it will give you the option of validating the request, and that request should supply a user ID and password. So when I say the basic authentication is nothing but a credential of your user ID and password, and the API policy will allow to configure for only one user. Okay. And before Mule 4, there should be a security manager to be created to to configure this credential. But once the Mule 4 comes into picture, the security manager automatically part of the Hinos built, so you don't need to configure anything explicitly. You just have to configure your credentials in the API policy, so that that particular credential will be validated against API call to confirm the valid identification of that particular request. So it is HTTP authentication simple policy it is ideally required and not required for any actual real-time implementation, but this can be used for the any kind of testing purpose or the validation purpose. Okay, but not this this not recommended for any of your actual implementation. And there is another policy which is LDAP. So LDAP is something you guys are might be aware of, that LDAP system, which is a repository of having all the user credentials and user access for the particular enterprise. So LDAP system will be like separate system that holds the entire thing. So it is a kind of one entry point for people to make access to the enterprise. So it will maintain all the user details in terms of the username and the password. And this LDAP connectivity is the policy will let you to configure your LDAP to connect to the LDAP system. So whatever the credentials that is coming in the request, so this policy will make a call to the LDAP system, and it confirms this particular user ID and password is available in the LDAP system. So then only it will allow. In terms of the simple authentication, you're configuring the user ID and password within the policy itself, and it is only a single user can be done. Whereas the LDAP is more than it's another hub of different system that is going to have it, and it is going to be more than one user, and it is kind of facilitating the call to the LDAP to do the identity validation. So this kind of LDAP authentication, and this is something can be used in terms of implementing your real-time scenario as well. Depends on your enterprise requirement, because in most of the cases LDAPs have kind of been deprecated, and they are going for single sign-on login, and moreover they are going for OAuth based. So this is kind of deprecated one, not the policy, but the the implementation of LDAP itself, I'm saying. So these are the two basic authentication policies we have in security. And the next one is on the payload threat protection. So what is the payload threat protection is? So you have to consider in a way that, okay, uh, to make your because you want your API to be stable, but you have to ensure that how this can be stable is, you have to allow the request that is only specifically accepted as per the given standard in the structure. I can make your API to be unstable by giving my payload as which is I can bombard the request by giving tons and tons of values to it, like giving a payload thread to the API, which makes your API to go for unstable position or make it as in a hung state, just because I'm by increasing my payload structure. So what I mean by increasing the payload structure is where I can you know uh, give the like a particular field is supposed to have 10 particular letter, but I can give that particular field with the 1,000 letters. So to process that, to understand and parse it in terms of the traffic layer, the API may not be able to do that. Okay, so this kind of attack you can expect in over the internet, or to your as well as to your API security layer. So how you can tackle that is through the threat protection policy. So the threat protection policy given for both JSON as well as XML. So what this defines is, it will define that, okay, for example, if it is a JSON, so the threat protection policy can say that, okay, the incoming JSON should have only these many number of nested arrays, and each arrays should have only these many entries of fields, and and also it can say that what would be the maximum length of a value for each field, and also it can say that how many element entry should be presented within an object. So it can gives a categorization that you can limit the payload structure to say that only this one particular of request is accepted. If it goes beyond, immediately can reject the request at the gateway layer itself before it even reaches to the API implementation. The same goes for XML threat protection as well. In XML, the same way, like it also talks about how many nested array can be presented within the XML structure, as well as what would be the the string length, as well as the element length of an particular attribute. That could be a child element, or it could be a parent element. So everything can be defined and restricted in a way of to prevent this payload attacks. So if any of the requests being failed, then definitely it will going to reject the request with stating as HTTP 400 as a bad request. So these two policies plays a vital role in your API layer. Okay, and the next one is on the security policy of it's a IP allow list as well as IP block list. So this IP allow list, it will limit the traffic to your API from a only particular specific APIs. Okay, I mean specific systems. So for example, you want to get the API call only from the two API client, but in your interface you have 10 API clients, but you want to have this API to be served for only two API clients. Then you can configure those API clients IPs or IP ranges, or you can even configure your CIDR block of the subnet, to allow only the request from those source systems. So by doing so, you are restricting the traffic to make your API stable. And the another policy is the IPA block list. So the IPA block list is something, it is like the quite opposite than the allow list, because allow list you are restricting the traffic to a specific number, but block list is something you are mentioning that you don't need request from a particular source system, but you will accept the request from all of the source system as well. But this particular policy is not recommended at the at the max, because you are going to restrict only for a certain amount of source system, but you will be still allowing the request from multiple source system as well. Okay, probably you can use both the allow list and block list together as a combination to to make sure that you are going to access it in terms of the API invocation. But using the block list as a, in a separate policy, that will kind of make your API vulnerable, just because, for example, if your API is exposed in internet, right, publicly can be accessed, then this block list is not really prescribed. Only you have to go with the allow list to ensure that what type of IP ranges you can accept. So these are the key difference between the allow list and block list policy. And the next one is I'm going to over. So before going to that, is there any questions so far so that I can take in? Giri or Shubham?
There's no questions in the chat. So anyone have any question, please speak up if you want. You can take this as no, and then we can go forward.
Yeah, sure. Cool. So the key important authentication is, and most famous authentication here is the OAuth 2.4 token enforcement API policies. So OAuth 2.4 is something that like predominantly used across the enterprises for any API calls. So it is ideally like how you did the API basic authentication, so where you just going to pass the user ID and password to ensure it. Okay, but what if all the credentials stating that the API client, they don't want to share the credential? Okay, instead they are going to pass a token. Okay, and that token will be validated for the identity of the API client. So how this is done is, that's where we have a OAuth provider. So this OAuth provider, what it does is they will generate a unique credentials for each of the API client. I mean, they will be like sharing it with them. So whenever there is a API call or API invocation needs to happen from the API client to the API implementation, so they need not to pass the API client need not to pass the user ID credential. They just go to the OAuth provider and give their user ID and password and get the token for them. So that token can be used for a certain period of time, because that token is not a lifelong token. It could be a a short term token that could be like having a time to live of probably like 1 hour, or it could be a 6 hours, or it could be a 24 hours of window. Okay, but that token can be used for any further API call to the actual web API implementation. So by doing so, the web API client will make a call to the OAuth provider, and they take the token from them, and using the token, they will pass that token, part of the header to the API client. I mean API API implementation. So when it comes to that, the MuleSoft OAuth API policy takes the token, and that token is used for validation. So how it does is, the API policy will make a OAuth token validation API call to the OAuth provider and ensure the token is valid. So only if it is valid, the response from the OAuth provider states that it is valid, then only the API policy will allow the traffic to the actual web API implementation. So in Anypoint platform, so we have over 2.0 policy that is available, and we have in-house OAuth provider as well, which you have to install in the runtime. So using that, you can generate a token for your web API clients, and they can directly call to your OAuth provider and get the token for them, and they can pass the token to the policy, and policy will again talk to the in-house OAuth provider and validate it. And once the validation is successful, it routes traffic to the actual web API implementation. But in general, this is a in-house OAuth provider, but in general, any enterprise, they would be having a specific OAuth provider bind to them. So MuleSoft supports the below OAuth providers such as Ping Federate is one of the most famous one, and OpenAM is again a most famous one, and we are also having OpenID Connect set of validation. So OpenID Connect is is kind of where we say it is OIDC Connect, which is like equivalent to what we have in Salesforce, OpenAM, and Azure AD. So these things are kind of an alternate to the MuleSoft OAuth product that is available in the OAuth 2.0. So this is one set of security we are going to implement, and if the token validation is failed, within the OAuth policy itself, then the API policy will respond back with HTTP 401 to the API client. So the next one is quality of service. So this quality of service is a most important part in the API governance. Okay, so when you talk about this, as I said, it has to regulate the traffic to the API. Okay, so when I say it has to regulate traffic to the API, so it has to say this API client can call the API only this many number of time within this particular period of time. For example, it can say that this particular API can accept the request up to 1,000 for 1 minute. Okay, if it goes beyond that, those requests will be rejected, and then the API client has to call back after 1 minute. So by doing so, you are kind of regulating the traffic to your API. Okay, and we have two options here. Okay, one is SLA and one is non-SLA based. So SLA is nothing but service level agreement. So first we talk about the non-SLA. So non-SLA is if you configure rate limiting for your to your API, which means let's say you say that okay, I'm going to accept only 100 requests per minute. It means that irrespective of your API client, so let's say there are 10 API client is going to make a API call to your service, which means what will happen is only 100 requests is allowed to the to each of their API client, like within the 1 minute of period. If it goes beyond that, then the rate limiting will reject those requests, and then they have to wait for a particular period of time to before making another API call. So this is a non-SLA based. We have another option called SLA tier, which is again a service level agreement. So in this, you can define specific rate limiting configuration specific to each API client. For example, the client A having a need of 500 requests per second, whereas the client B just having a more needs, where we can say that they require 1,000 requests per second or 1,000 requests per minute. So you can have those SLA based policies bound to a specific API client, and this is where this client ID enforcement also comes into picture. So this SLA based policy is bound to the API client by using the client ID enforcement, because the particular rate limiting policy has to know which API client is calling me. Okay, so how it can validate it? So that's where it uses internally uses the client ID enforcement to validate the API. And once the validation is successful, then that particular SLA is applied to that particular API client. So that's how it maintains a state of the rate limiting per API client using the SLA. And again, if the call to the if the call to the API is goes beyond the configured rate limiting, then it is going to return back the HTTP 429 till the period of time could exit. Like for example, if it is configured 500 requests per minute, then like let's say within the 30 seconds itself the 500 request is exhausted, then whatever that call that's going to come for next 30 seconds from the particular API client, they are going to get this HTTP 429. So this is how the rate limiting is works. And the next one is spike control. So spike control is the latest version of throttling policy. So ideally what the spike control does is like it is kind of going to allow the request to process to get processed by your API within the configured limit. So for example, you're going to say that let's say API process 100 requests per second. Okay, it means what it does is if you're going to get let's say you're going to get around 150 requests per second, then the spike control policy what it does is it will first allow only 100 policy to the request to the API, and then once those particular quota is kind of refill, then it will retry with those remaining 50s. It's kind of queue those remaining 50 request, and then push it to the API implementation. So by doing so, it keeps your API in a stable manner. For example, if because of the API stability, because this API stability, it is not only with API policy, it is also depends on what type of infrastructure your API policies get deployed. What type of the CPU percentage and what type of your memory that is allocated to the API, everything adds in. So that's where the spike control policy plays a key role. Okay, if you confirm that your API is capable of processing only 100 requests per second, then the spike control policy can manage that. But if you don't configure that, and if you get beyond 100, then definitely those API requests going to make your API unstable. So that's how this spike control policy used. And the next one is HTTP caching. So this HTTP caching, so you even in web app implementation we have a caching available. Those are in-house caching as part of doing so. But before even going to web app implementation, you can cache those in the policy layer itself. Okay, and this is called server side caching. Okay, this is one of the options, server side caching. So at the maximum of 1 MB data can be cached. So what type of message can be cached? You can cache the entire HTTP response for a particular request. It could be your entire status code and response headers given in the HTTP request. So these entire things can be cached, and the allowed size is maximum 1 MB. And by doing so, you are improving your API reliability to your API clients. And this just not only the API layer, you are also having an option to do the caching within the API implementation as well. Because for example, we have a three layer of approach, that experience, process, and the system layer. So when the API client making a call to the experience layer, so you can implement a server side caching in the experience layer, but the experience layer becomes the API client for the process layer. Okay, so that's where you can again implement caching in the API implementation of experience layer to cache the response from the process layer. So you have a number of options to implement the caching. These are completely comes under server side caching as far as the API client, real API client concerns. And the next one is transformation. So the transformations are it is not about the transformation of your payload, but you can do the manipulation on the HTTP header levels. Okay, so whatever the incoming request or outgoing response, okay, in both of these things you can really use these two policies called header injection and header removal, where you can add the headers to the request or response, or you can remove the specific headers from the request and response. So why do we need this policy is something, because there are some static headers you can add for the policy which is required in the enterprise level, which is required for your API client as well. You don't need to keep those things implemented in all your API. You can just simply configure on the API policy level, which can take care of it. For example, you want to respond couple of custom headers to the as part of response to your API client. So you can very well go and simply configure using this policy instead of doing that in the API implementation. So this is one type of transformation policy. And the last one is troubleshooting. So the troubleshooting policy is what we can talk about is a message logging policy. So this message logging policy you can configure in the API manager level, so which can capture the incoming request as well as the outgoing response. So what level of information you're going to capture, it's up to you. You can capture the entire payload, or you can capture the attributes of the mule event, or you can capture the specific key elements that is there either in the header or in the payload. So or you can even capture the error messages. So this policy is can be like kind of it's a plug and play policy where you can configure whenever it is needed. For example, in production you want to need to configure you are not enabled the logging for any of the key or crucial AP implementation because of some kind of confidential implementation. But for troubleshooting purpose you want to enable it at the time of production issues, and it is allowed for like probably period of for 30 minutes. And instead of you go and redeploy your implementation by enabling a logging, where you could just come to the API policy and just do the plug and play here, just enable the policy and do the troubleshooting, and once everything is fine then disable the policy. So that's what this policy used for troubleshooting. And irrespective of it, you can also configure this API policy for long term usage as well. It depends on your requirement. So far we have covered the list of API policies and discussed in terms of why it is needed and how we are going to configure it. And now we are going to discuss about some certain use case scenarios. So let's say we have a web API client, and which is a website, and the NFR here is you're going to do the user authentication. Okay, and this enterprise having an LDAP. Okay, so that is first point. And second one is the particular API you're exposing to the API client having 3 API resources. Okay, probably let's say there are 2 get calls and then 1 post call. Okay, and the expected throughput is 1000 requests per second, and then the maximum response time of for each request is 500 millisecond. So this is the highly expected throughput. And then you have to consider that though we have 3 layered approach, like experience, process and system layer, you have to define for this particular use case scenario what are all the API policies that you can configure on each layers. Okay, first let's come from the experience layer perspective. Okay, so as the use case indicates, so they need a LDAP authentication. So very well, for the authentication perspective, you can go ahead and configure the HTTP LDAP authentication, and you can configure to the LDAP server. So this particular policy will route the request to the LDAP server in order to the authentication. And the second one is client ID enforcement. So client ID enforcement comes as part of the compliance to identify your API client. So there is a two different thing. The API client which one makes a call, you know which has to be compliant. So this particular policy only will validate the origin of the request. Okay, where it comes from. Okay, not the user details of the request. Okay, there's two different authentication. So client ID has to be there in order to validate the origin, or the API client is making a call. Okay, in the HTTP LDAP you're going to use the credential of the user that is available in the payload or available in the header, because the user can change with respect to each request. Okay, so that's why you have to get like clarity on like why we are using the client reinforcement and why we are using the LDAP policy. Okay, and second point is it says the throughput should be high, so where you can go for the rate limiting. And again, it's a non SLA or SLA based. It's for this particular use case we can go with non SLA rate limiting, where you can configure 1000 requests per second. And as one important point you have to mention and identify that this is a API client where which is hosted in the website. So that's where you're going to get the API call. So definitely you have to enable the cross origin resource sharing API policy to allow the calls to the browser. And then API allow list you can use. So these are the API policies I'm talking about in terms of possibility of assigning API policies. This is not something I'm mentioning in a way that only these policies to be applied. These are the possibility you can apply this apply this policy to the respective layers. Okay, it completely comes to the scenario of which policy you're going to configure. It depends on your enterprise requirement. And even API allow list, you can do it in terms of allowing the traffic from the particular API client. And then most importantly, they are expecting high throughput. So when you say high throughput, the server side caching is mandatory. So you can very well implement the HTTP caching, the experience layer. And coming to process and system API, and the process and system API as well can have the client ID enforcement, to ensure like what are all the experience layer is, it's going to, for example, this process and system APIs or can be reused by multiple experience layer. So you can limit that as well to ensure only you are going to get data from them. And then IP allow list can be used to regulate the traffic. Even you can include the HTTP cache, because from the source system they are just going to make a call to the MuleSoft. But in the MuleSoft we have multiple hop of layers, like experience layer, process system layer, and system layer talks to the actual backend. So wherever it is possible, you can enable the HTTP caching, and also you can regulate the rate limiting according to the need. For example, if it is being reused by multiple API, you can enable the rate limiting. And here as well as non-SLA is applicable, non-SLA is applicable. So this is one of the use case scenario. And the second scenario is, consider it is going to be like more than one third party system is going to invoke the API. So when I say the third party system, it may not be a website, it could be any in-house component, or it could be a any CRM system, or it could be any kind of database based system which is going to invoke your API. And you can get requests from more than one API client, and which really requires a strong authentication. So you have to authenticate the request for each of those clients. And then the API that you're going to implement is going to have three API resources as like the previous one. So out of three, two are safe get methods and one is a post method. And the higher expected throughput is subject to change based on the API client. So as I said, the API client require like they have 200 requests per second, maximum response time of 2 seconds. And another API client can say that I need 500 requests per second. So it will vary according to the need of the API client. Okay. Also, they say that no request loss is expected. Okay. And the process and system API is being reused by other experience layers. So this is complete use case. So then how you are going to define the API policy on in these layers? So that's where like you can, let's talk about some experience layer. So as they say, we are going to have a call from multiple third-party system, and we need a strong authentication. So that's where we are going to use HTTP OAuth, and we are going to implement SLA-based rate limiting, because the requirement of rate limiting will change depends on the API client. Okay, the API client one will have a different set of requirements than the API client let's say API client B. And you can also restrict the traffic by regulating using the IP allow list to ensure that you are going to get only the request from the concerned API clients. And then to increase the throughput, HTTP caching is recommended. And coming to process and system layer, so as is mentioned, this process and the system layers are going to be used by multiple experience layer. You can use the client enforcement to validate the incoming traffic. Also you can regulate using the IP allow list. Also you can implement the HTTP caching to make the API more reliable, because it is going to be used by other experience API layer as well. And then SLA based rate limiting is applicable here. And more importantly, we can apply the spike control. The spike control, as I mentioned, it is going to queue the request if it is exceeds the quota, so that it ensures that the message not getting lost. For example, if you're getting more requests than expected, and you don't want the process and system layer to go overburden, then you can have the spike control to to limit those processing time. And then you can, because this policy will again queue those requests and reroute to the layer again after the quota is open. And eventually, like, you can also apply the HTTP caching, which is a server side caching for these scenarios. So this is kind of mentioning in a way that there's a possibility of assigning API policies on the respective layers. But the final call in terms of which policy is really required on time of implementation based on the requirement, as well as the NFR that you're going to consider specific to your enterprise. So these are the use case scenario. and I'm just going to get into a short demo. So this demo is something like I have kind of developed one small API. This is not like for demo perspective, I just made a generic utility API, and I have configured a few set of important policies. Is there any question before I start the demo?
Yes, Vijay, there is a question from Jay Kishan.
Yes.
So when the HTTP response is greater than 1 MB, so how efficient way of the server side caching can be done?
Okay. So the policy limitation is you cannot log more than 1 MB. Okay. So that's where like you can do the server side caching in the API implementation using your if it is a cloud app, you can enable with the object store v2, or if it is like a if you're using RTF, you can do the persistent gateway in order to enable the logs. Like for example, I can tell you one of the use case scenario where we have implemented. So where we are running with the uh, runtime fabric deployment model, and there is a scenario of we are getting a pricing request for the products. Okay, and the payload would be like more than a few times, it will be more than 1 MB as well. So instead of we are doing the in-house caching, so we enable the persistent gateway, and we efficiently log using the persistent gateway. Apart from that, there is an option that the payload size is really more, then you can go for logging caching those in the external database as well in the in your API implementation. So it's ideally your recommend will decide which one to go for. Does it answer your question?
Yes, Vijay.
Yeah, thanks.
Yeah. So is there any other question, Gary, before I go jump on?
No more questions in the chat.
Okay. Okay. So let's see a short demo here. So I have created a small API, which is a customer API. There are two HTTP methods. So one idempotent method, which is a get method. So where I am going to pass a customer ID. So where I'll be getting a customer information. So which is going to have the customer personal address and the contact information. Okay. And another endpoint is I can create a customer by passing all the required information, and I can in return I can get back the customer ID in response. Okay, this is a very simple implementation in the API level. But what are all the policy that I applied to guard this, to guard my API, and secure my API? So let me show you the samples policy that I've configured. So first one is I've configured rate limiting on SLA-based. So currently I'm considering that this particular API going to be invoked by two different API client. Okay, and the SLA is different for each API client. So I'm mentioning in a way that so there are two tiers I've defined. The tier one will say 5 request is allowed per minute, and the tier two will say 10 request is allowed per minute. So the API client who's registered for my API, the API client A has chosen the tier 1, and the API client B has chosen the tier 2. And by using this, the client ID enforcement automatically added as part of this rate limiting policy, and the compliance is comes into the picture. Now the second policy is I'm just currently using the simple basic authentication. So I'm just going to give the same credential to both the clients. Okay, because currently I don't have a LDAP setup, and so that's why I'm just assigning them simple authentication, but this is just only for the testing purpose, not recommended for real-time implementation. And the third policy is JSON thread protection. So I'm defining what would be my payload structure. Okay, so I'm defining each one of the entry level, like what would be the how many entries should be presented within the object, and what would be the string value length, what would be the entry name length, and how many nested arrays should be there. So I'm just defining restricting within these parameters. So if it is goes beyond that, then the request should be like rejected at the AP policy level. And also I'm like currently, like I'm just configured my IP address of my machine, so that the API will receive the request only from my machine. So I'm just regulating the traffic only from my particular local machine. And also I just implemented the header injection, where I'm just adding a custom header in the response, just stating that, like just giving a message like thanks for the API invocation. And the final one is I'm enabling the message logging for the response part. So whatever the payload that goes out in the response, those informations are getting logged. So I have defined these policies in the because there are two methods, right? So for the first method, I have I've used for the payload, and the second one is I used for the attributes level. So let me just run the, yeah, I think it's already in running. Yeah. So this is the customer request. So I'm just going to create a customer. So in order to do that, so what are the things I'm passing out here is, I think my Postman is kind of stuck. Let me open it again. So fine. Yeah, let me make one quick call to ensure that API is working. Yes. So so this is my consider this is my API client. So here first let's go one by one. So currently let me go to the get customer call. First let's validate our client credential as well as the SLA tier of rate limiting. So currently I have two API clients. So currently this particular client A going to identify itself using this client ID and client secret, and the tier that the API client has chosen is 5 requests per minute. So I'm just going to make 5 calls now. So all good. when I make a sixth call, so I'm getting the quota has been exited. So I have to wait for next probably like 40 or 30 seconds in order to make the next call. Okay, so where it says that my headers will say that, right, in terms of you know available quota is exited in a way. And when I go with the second one, right, so it is with the like around I configure around 10 requests per minute, so it varies. So I can still like go ahead and make a call around 10 times within a minute. So my the curl was not working with my machine, so I'm just making it manual in Postman now. Yeah, it said the quota has been exceeded. So after making those many calls, so ideally this is how you can identify that using this the client area identification. It identifies the API client and it applies a particular rate limiting model to that particular API client. So if any other API client want to access, definitely the client area enforcement will say that invert ID or secret. So this is one way of securing and making a compliance of your API, as well as handling the rate limiting of the API specific to API client. And the second policy, what I mentioned, is on the HTTP basic authentication. So that's where I'm applying this. And what I've done is I have applied this HTTP basic authentication only for the post call, not for the get call. For because I'm just opening up the read operations for all the both API client, but only for the altering the resource or creating a resource, I'm asking for the basic authentication. And the credentials are simple, like test is a username and test123 is a password, and they have to pass as part of the basic authorization header. And when they pass, I'll be able to create a customer and give the customer ID back. So this is done using the HTTP basic authentication. And the third one is JSON thread protection. So I already defined the number of values in it. For example, I'm going to increase the value for one of the, let's say I'm going to one of the customer. Let me increase the value. I've defined around some 25. Let me define it more. So the JSON thread protection, it validates it. It says that string values length been exceeded, maximum allowed is 25. So this is how this JSON thread protection policy works, and it ensures to prevent all the payload attack. I mean, it ensures that your API is protected from all the payload attacks. And the fourth one is IP allow list. So let's say if I change to different IP, for example, currently it's in front, let me configure the 105. So let's wait for the runtime plane to download the latest changes from the API. So the runtime plane, there is a sync up will happen between the control plane and the runtime plane. So whenever you make a change, automatically, within 60 seconds, those changes will get reflected in the runtime plane. So currently, I've reconfigured the IP allow list, so I should be seeing it here now. So before I'm making a call, so we have to give a time for a minute. Yes, it says the IP address is invalid. So it is expecting 104. So uh, what I'm going to do is I'm just going to rechange it. So this is my IP. I'm going to save it. Let's again wait for a few minutes. It's yet to get updated. Let's wait. Yeah, it's, you can see the policy being downloaded. The latest update is being downloaded from the control plane to the runtime plane here. So when I make a call, it's succeeded. So the traffic is regulated here. And the final one is, there are two more: the header injection and the message logging. So what I've done is I have added a response header in all the API call, mentioning that the custom address I'm just adding here. So it says that, you know, thanks for the API invocation. So just I'm just adding using this particular policy. And finally, I'm also doing the message logging. So what type of message logging? I'm logging the, the request in the request part. I'm just logging only the header and attributes, and in the response part, I'm just logging the payload. So this is the, let me show you again. So first, let me do the get call. So when I make a get call, the response is logged, the payload is logged. In the request, it just logs only the attributes, like, it logs all the header attributes, IP details, everything it logs. And when I make the creation of a customer, the same goes here. It logs the response of the, create customer call, and then the request attributes. So this is I'm achieving through this message logging policy. So that's all from my end. So we'll go to Q&A. Any questions still I can answer?
Vijay, there is a request from Gaurav.
Yes.
So can you show an example of a custom policy where more than one policies are used? What rules apply in those cases?
Okay, you mean custom policy?
Yeah, he mentioned as a custom policy. Gaurav, you want to speak up? I think. Gaurav, I think mic is enabled for you.
So what was the question again? I didn't get it fully.
One second, let me come back to the chat. Can you show an example of a custom policy where more than one policy are used and what rules
Okay.
apply in those cases?
Okay. So
Like multiple, yeah.
So to give a detailed answer on this, so probably, like, in the next session, I'm completely going to talk only on the custom policy with, how we can create a custom policy, and all the aspects of custom policy in the next session. So where I can able to answer in detail on that.
And one more question from Ankit: How to identify and service how identity and service provider differs?
Okay. So the identity provider, I think the question related to OAuth, I believe. Okay.
Yes.
So this particular identity provider, so they both act as a identity provider as well as a client provider. Okay. So for example, if you take Ping Federate, so Ping Federate, which is an in-house capacity of, holding all your, user credential, roles that has been set up for the particular enterprise, and that is going to act as your identity provider. So even that you can ensure that, you can enable the SSO login in, even if anyone wants to log into the anypoint platform using that, and that becomes your identity provider. So when to the client provider, you can use the same set of users, and those users can be assigned, as an API client, and you can generate a token for them. So for example, in one of my use cases, I mean, when I say use case, when one of my client engagement, we are using, Ping Federate as a both identity provider as well as the client provider. Does it answer your question?
Yes, it answers. Do anyone have any more questions to ask?